Hi. In my last tutorial, I was talking about how you can create objects in Free Pascal and Lazarus, and basically these objects are let's say the key elements of an object-oriented language, where you can define certain blocks. Let's say so if we consider an object as a kind of block, then these blocks can be used as they are, or you can create child elements from these child objects from this, and you can basically inherit into these child objects the behavior of the parent object, and you can extend the solution, how the object is behaving to the in the application, and via this kind of let's say inheritance and extension of the objects, you can basically use up your previously created objects. And typically the nowadays language is what you can use for programming for the web, for iOS, for Android, or even for desktops. These languages like Objective-C, Kotlin, Swift, Java, PHP, basically all of these are object-oriented languages. Today I would like to talk about the classes, because in Free Pascal we have objects and we have classes, and basically the classes are let's say um, same elements like the objects, just the difference is that by the objects you can define as a variable, and you can use them as a variable at the end. Of course, you can also create them dynamically, and then you can refer to these objects based on their pointer variable. The classes are basically behaving already as a kind of um, a pointer type thing. So basically, the objects are created in the memory, and the variable which is holding the object itself, or the class itself, these are already pointer types. So because of this, that the basic setup, or the basic concept for objects and classes are typically the same. Using them is almost pretty similar. However, handling the classes, I would say, a bit easier, because you don't need to really focus on pointers, and if you want to use a pointer, or you want to use a variable, basically you will simply use a variable name which will refer to the object itself, or to the class itself, and and then you can use it in your application as it is. Of course, you can also define arrays from these, or you can dynamically create additional elements, but then you just need to refer this maybe as an array. So let's see how you can create a class. So in this very simple application, I was creating a form where I have some buttons, and these will relate to certain elements of the class definition, and to show basically how you are building up an object-oriented application. I created two units actually. So one unit is the main unit, which is containing the form, and I created another unit for the child class. I called it second class, and this will just implement a second class type inherited from the first class, so from the parent class, and I will call them just like this in the application. So let's see how we can do this, and I jump immediately to the class definition, because the rest is just to basically operate the form itself. So I have the buttons and procedures defined for that. but just let's see how the parent class is defined. So the first difference is that what you can see here, that when you define a class, you name the class, and actually you need to define this under the type inside your application, and typically inside the interfaces you have these type definitions, and then you define the class name, and then you define it as a class, and you can define the parent object, so from which object you are creating your own object. So basically this base object will be the parent of your object, and you can inherit the actual elements of the original object. So in this case, I was using the T object because when we are talking about classes or class type um, operation, everything should be started. I mean, the basic classes should refer to the T object class, and from the T object class we can basically create our own classes. But of course, once you define a class or a subclass or a child class, then you can also use it into your the class definition. So as you will see in the second class, the child class itself is using the parent class as the parent. That's why I called it like this, to show it like this one. And this the child class will inherit some things from the parent class, and of course you can define additional functions or procedures in your child object or child class, and then you can extend the behaviors, but you can also use up the original class elements. So these classes, of course, can be defined as classes which can be inherited later on, and if you don't want this, so if you want to block the inheritance of such a class, so you don't want the user to change your original class definition, or even use it up and add functions to it, so to define a child object or child class based on your class, then you can use the sealed command itself, or the sealed command itself behind the class, and then basically this class will be sealed, which means that it can be used in other units, but you can't use it as a parent class. You just can use it as it is. Okay, so to go through how you can define the class itself, of course, it was already discussed in the object types, so where you define objects, that you can have different kind of modifiers for the fields, functions, and procedures. And these can be private, protected, public, or in classes you can also have a published version. In the classes, you have a bit more than in the objects. So you have, as you can see, a strict private, strict protected, public, and published. And the difference between a private and a strict private is that if you define a variable, or I mean a field of the class as private, that this private fields or functions or procedures can be accessed only from the same unit, but it can be accessed from any other classes. So if you if you define a subclass, you can still let's say get these fields or functions reached from it, but just from the same unit. So if you define these functions or procedures or fields here in the parent class, and you define another unit and the child class there, you can't access these values or functions or procedures from that other unit. This is a kind of protection. So if you want to let's say define your classes, and you want to give to other users your compiled library, let's say, then the user will not be able to access those parameters or those functions what you are defining under the private section. The protected is basically similar to this, but this allows the descendants to access these values or these fields and functions and procedures in other units as well. If you say that it's protected, then it can be only accessed from the same unit. And for the private, I did not mention, but for the strict private, you can only access it from the actual class, and you can't access it from other classes. Okay, so then the public is by default it's accessible anywhere. So basically, if you use it in the same unit or other unit, it can be accessed as well. And the published is a specific one. I will explain later on what does it mean. So if you define fields and procedures, of course you can define them as explained, that it depending on how you want to use it or how you want to have the inheritance controlled. Or even just the accessibility within the applications from different units or from same unit, then you can define the point or the position of these definitions at the right place. So there are two specific, let's say, procedures in a class definition. One is a constructor, and the other is the destructor. The constructors can be defined as you want. So basically, you can name them as you wish. However, the original T object constructor is defined with a create. So if you want to define your own constructor, and as you can see, I defined it here with the init name. Then, of course, you need to make sure how you call the original let's say constructor procedure, because typically if you name it on a certain name, and you just simply use the inherited keyword, then the inherited keyword as it is will not find the original init function or init procedure, and then it will not call anything. So basically the original object will not be defined. And this might create issues because, of course, when you are creating an object, in return you should get basically a kind of a pointer type back, because you need to identify finally this object which is created with a with a pointer to a memory place where this object is located and where it can be used. However, for the destructors, you need to always use the destroy keyword, and typically if you are using this keyword, you need to use also the override, because you need to override the original destroy um, function or destroy procedure with your additional let's say cleaning processes where you might need to clean out some sub elements of your object. So to make sure that you are freeing up the memory, you also need to take care about this, but you also need to call the parents let's say destroy function, otherwise you might not clean out everything from the memory. So these are the two specific objects, and let's see how you can define this, and then we can also talk about the inheritance of the different let's say functions or procedures from your parent um, classes. So if I'm going to the definition of the parent init constructor, as you can see, the first line of the parent or the t parent init constructor is the inherited keyword. And here, because the original object is not using the init procedure name but the create, I need to use the inherited with the name of the original constructor name. And then I have here a field initializer as well, because I defined a field, and I will explain why this field I defined here. This will be used for something which I need to also explain later on. The destructor is very simple, so actually, because I didn't have anything which is dynamically created, so I was not allocating any memory dynamically inside this little application. I don't need to use any other cleaning process, just to call the original inherited destroy destructor of the t object class. So this is very simple, and as you can see, if the parent object or parent class procedure name is the same as the current one what you are using, then you can use the inherited keyword very simply like that. But if you have parameters for a parent object procedure, then of course you can also use again the similar thing, the inherited destroy, for example, or if we are talking about here a procedure, as you can see, if I would have a parent set name procedure with some parameters, then I would be able to call that inherited procedure with that call as well, and then also add the relevant parameters to that procedure. Of course, there if you redefine the same procedure or function name, but you are changing the variables what you are, or the parameters what you are giving over to these procedures or functions, then you can of course change it. The important thing is that when you call the original parent procedure or function, you should take care about that function or that procedure is called with the right parameters, or just those parameters which are relevant for those variables. Okay, so this with this I explained basically the constructor and destructors. One additional thing, that if you want to have different constructors, so you might have, for example, if we are talking about maybe coordinate systems, and you are just having a two-dimensional coordinate system or a three-dimensional coordinate system, then of course the constructor itself might be different, and then you can also define multiple constructors, and depending on which one you want to initiate, or how you want to initiate the application or that object, then of course you can define another init or other constructor as well. So just to show you, and I will not define of course this constructor, but I might have the init function with an x value defined like this, um, and then I would also need to have this this init function, and but let's define it. So if I would like to use it like that, let's copy this one and then define the x value. Oops. And then here, of course, if I want to do it like this, then I would create it like this. So in this case, when you want to init your object, and later on you will see how we can do that, then I will explain also this one. So the normal, let's say, definition of procedures and functions are not different from the definition of the other ones. I mean, when you are defining functions or procedures in a normal or a very simple application. One additional thing about creating procedures within a class is that you can define a class procedure just instead of defining a procedure, and the difference between a class procedure and as you can see also it defined as a static procedure. These procedures are, let's say, behaving as procedures like others, but these are always referring to the original parent class. So if you are defining these objects on a way that you define a child object from a parent object, and inside the parent object you have this static procedure defined. And when you are looking for the object itself, that which one is calling this static procedure, it will always report the original parent procedure. So it will not report it back that you are using a child object. It will always define or always report back the parent object. So whenever you call it, and inside the object you call the static object, that will always report back that it's coming from the parent itself. When you define procedures, you can do it simply using the procedure or function keyword, and then without any additional modifier behind. But you can also use the virtual keyword. As the documentation says, that basically the simple or normal procedures and the virtual procedures are, let's say, different from that point of view, that when you define a procedure with a virtual keyword, you can only override it with the override keyword, just like here for the Destructor. I made it here, but also I prepared it here in the second class, the same my virtual procedure with the override let's say modifier at the end of the procedure. But as you can see that in the set name procedure I was not using anything. And however, the documentation is saying that that if you are not defining this second virtual procedure in your child objects with the override keyword, then you can't call, or you can call the inherited keyword inside the procedure, but it will not call the original parent procedure at all. But as I have seen, the only difference is that if I'm not using the override keyword, like here I have it, and when I make the build, I don't have any message about any issues with this definition. But if I define it again as a virtual and compile it again, you see that the compiler is already saying that an inherited method is hidden by the myVirtual. So basically, this procedure theoretically should not call the inherited or the parent procedure, but as I have seen, this is not the case. So when I'm running the application with this setup, and I'm pressing the parent function or parent procedure, you can see that it was writing that my virtual method is called, so my virtual parent is called. When I press the child virtual, I get again the my virtual parent and my virtual child. So basically, the inherited keyword was still working. So I'm not sure if this is an issue with the compiler itself, but I think it is safer if you keep the original, let's say, definition. So if you want to define the procedures like this, then you should be calling the override instead of using the virtual keyword. So if you say here that override, then the most compatible solution you have. So this will do the same as before, so it will call both of them, but as you could see, there is no message about this. So it's not saying that the original procedure and method is hidden. There is one additional option what you can use when you are defining a procedure, and this is called the message procedures. And the message procedure is something special. So basically, this you can use to call kind of callback functions or callback procedures from your objects to another object. So if you define such a message a procedure with an identifier. So basically how you define it, you define the procedure itself, and then behind the procedure you are using the message and the message identifier, which I here replaced it with a constant number. So as you can see, this will be the message 1. And you want to call this or want to call the this procedure, you can basically identify it with a message number. And what this will do is actually that you can simply use one keyword, and here I'm using just one keyword or just one process with the send message button, and when I'm going there, let's go there here from here. So when I'm calling this send message, this means that I'm using the send message procedure from the child object. So I don't have this this procedure in the parent object, but just to show that how the parent object is basically let's say behaving to this message request. I'm calling here the send message procedure with the message number, and when I'm going down here, I'm sending or creating a message object, and then I tell to the child itself that I want to send this message. And basically, this message will be picked up by the parent class, and the parent class will call this message procedure itself, which I link to the message identifier. So as you can see, here the tparent my message taking the message object itself, and then it's writing out that message sent from child. And as you could see that this procedure itself is within the parent object, but when I want to call it, I'm just simply calling within the child object the dispatch let's say keyword, and putting into this keyword the message identifier itself, and then I also add a string which will be submitted to the procedure which will handle this message. So as you can see, this is a very simple and very easy method to call from one object another object which is already defined. Of course, if I would not have a parent object, then nothing would pick up this message. When I run the application and I press the send message button, you can see that the message was sent, and then the procedure which is belonging to this message was called. So basically, with this kind of solution, you can simply link an identifier to a procedure which is based on the message you want to send. We'll call the right procedure or right function. And with this, you don't need to know exactly which procedure you want to call. You just call the message itself, and the right procedure will be called. Okay, so the next thing is what I didn't talk about is of course the fields and properties. So fields you can define simply as kind of variables within the class, and depending on where you define them and under the private, protected, or public section, you are controlling also from where it can be accessed. So these are not really different from how you can create variables. The same thing applies for these fields, like I explained them in the object tutorial. So basically, you just need to link, let's say, the object or the class identifier or class variable and the property or field variable to the field itself, and then of course you can set and get the values of these variables. The second thing which is called properties is a bit different, because here with the properties you can build into your classes the actual value checking processes. So you can define that what you are accepting and what you are not accepting, and you don't need to check it in the application itself when these values are received, but already when you are trying to let's say initiate or initialize a value to that property, you can already run it through a kind of checking procedure. So if you check here, or if you see here the this property definition, where I was defining the property x as an integer value, then I had to define a read and a write procedure and function to it. So the read, let's say the read option is always a function which should give back the value for this x property. The write itself is a procedure where you are basically writing the value into the variable which is behind the x property. And it must be mentioned here that the property cannot be really used alone. So you always need to have a backup field, let's say, which is basically storing this value. So you are basically duplicating here the property itself, I would say, because you are typically not storing the property itself, but the value behind which is actually stored. So whenever you set the x property, depending on which field is related to this property, that field will be stored in the memory, and the x is just used as a kind of let's say alias for this value. So that's why you could see here that I defined an x value with an integer type, and basically this is linked to the property x. And then with the getX and setX function and procedure, which I defined here, I'm setting or getting the x value itself. So let's see how this function and procedure is defined. So it's here. So when I'm defining the getX function itself, then it's a simple function. There is no let's say variables or parameters are required for this function. So it's just a simple name function, and it will return an integer value, and it doesn't do anything else right now here, just giving back the x value field from the class. Then the setX procedure actually will receive a value, and this value should be an integer, of course, because we want to store an integer in the x value field. And then this procedure is checking in this case if the value is a minus number, and if it is a minus number, it will only store the 0. And I will get also a kind of debug message here which will tell that the value was negative, the x will be 0. And if it is 0 or above 0, then the x value will get the value itself. And how this actually used, and this is basically what it is used for, is that you can see that I created here two buttons. So one is setting the x to 5. The other is trying to set the x to -5. So if I'm going to this procedures, you can see that I'm trying to set of the class x value to 5. And when I'm trying to set the x value to 5, basically this let's say value initiation, value definition line will trigger the procedure which is checking that the given value, actually this 5 value, is acceptable for setting the x or not. And if it is yes, then it's saying or it will set the value. If I'm pressing the other button where I've tried to set it to -5, of course it's again calling the same procedure, and because it is a minus number, it will set the value to 0. And then to control it back that what was originally set, I'm taking the x property into this right ln lines, and it will basically call the get x function itself to get back the value. So when I want to say my parent.x equal to 5, then or equal to -5, then this line will call this procedure here, and will add the value to the parameter of this procedure itself. If I'm getting something out, of course, this will be it. And as you can see that I'm not setting the x here, nowhere. The x itself is, I would say, not existing at all, because the x will only represent finally this x value, which I'm setting with these functions. So when the application is running already, so I can test it. So when I press the set 5, you can see that x is 5. So it was okay. It was above 0, so there was no any action needed. But when I press the -5, then you can see that the procedure was checking it was a negative number, so x will be 0, and when I'm reading it back, as you can see, it is 0. Okay, so basically these are the things, and of course, as I mentioned, the classes can use the inheritance to redefine functions or procedure, and can change the behavior of the original object and so on. But one thing I did not mention, which I should be mentioning, and this is how you can, let's say, free up the memory from these objects, because once we were starting up the application, and I was defining the form activate, and then I was initializing the parent variable and the my child variable here, these two objects, with the init functions of these classes, let's say. And these are allocating a certain amount of memory, so depending on the size of the object, of course, and then this memory will be used to run the application, or call procedures or functions, and store the field values for the classes. But when I want to free up this memory, then I need to call the destructor, and actually the destructor itself is never used to be called directly. How you can call it? You can call the objects or the class free procedure, which will free up the memory from this object. But the simple free procedure call will not nil out the original object identifier. So when I'm initiating the form and creating the my parent and the my child classes, then these objects will be represented by their pointers. And when I want to free it up, and for that I had these buttons here, the free button and the free and nil button. So the free button itself is simply calling here the my parent free, and then I'm writing out if the my parent is still assigned, and also write out the my parent name. So basically, what was initiated, or what was linked to this object. So, but as you will see that with this call itself, the my parent as a variable will still alive, and this will still keep the original let's say parent identification or parent pointer alive. So this will be still in the memory, and you by mistake can start to call something, but this might be creating a kind of runtime error when you are doing this. So to make sure that you are also deleting or let's say unlinking the original memory address from the variable itself, you can call the free and nil function or procedure, but the call is a bit different because here you need to give the object as a parameter to this procedure or function. And with this, you are basically freeing up completely the assignment from the object itself. So this object will be completely freed up. So if I'm running the application again, and here I already have the objects defined. So if I'm pressing the set name, so now I have the John Doe and Jane Doe, and when I press the free button, you can see that I still can access the object itself. So I cleaned it out from the memory as a content. And that's why I don't have the name from that parent object anymore. But I still can call it. So this is still possible. So I can still see that the object itself might be accessible, but it's not. But when I call the free and nil, you can see that when I called it for the child object, it's saying that the object itself or the variable itself, the myChild variable itself, is not anymore assigned to the class itself. So if I would try to call the same thing here, that I want to write out the myChild name, then this will definitely create a runtime error. So here just change it to myChild. Let's run it again. Of course, here it will not cause any failure at this moment, but when I press the button free and nil, you can see that with this line I have an issue because there is no object at all, and this is not assigned to the variable itself. So you need to make sure that once you call the free and nil, you don't try to access the object or the class itself, because this will not exist anymore. If you just use the free itself, then you can still access it, but basically it will be completely nilled out, so you will not have any values available in it. So you should also not try to call it, but the memory is not completely freed up from this object. Okay, so that's all about classes. I hope you like this tutorial and you can use it for your applications. And if you liked it, then please don't forget to subscribe to my channel. And with this, I wish you happy coding, and see you next time.